are a sub 1 minus d. So that definitely has that form. And in fact, arithmetic is a linear function. All right, so if you have a linear function, mx plus b, you automatically know it's arithmetic. If you're stuck, just find the first couple terms and see what's happening whether you're adding or multiplying. So arithmetic is linear. Geometric is an exponential function. So I would have like 3 to the n power. That's how we're going to tell the difference in those. So it's arithmetic. And for an arithmetic sum, we're going to have our sum. I want to change my color. We're going to have our sum is going to equal, that's the problem with you guys being way back here. Our sum is going to equal my total terms, so my n divided by 2 times my first term plus my very last term. So that means I need to find my first term, my last term, and I have to figure out how many terms there are. Now normally, and that's why in that formula we have a sub 1 plus a sub n. Is a sub 1 the very first term in this one? No, what should it be, Jack? It should be a sub negative 1 is actually my first term in this one. So we're going to a sub negative 1 is going to equal 3 times a negative 1 plus 4, which is going to equal just 1. All right, then let's go ahead and find our last term. And that's going to be a sub what? A sub what is my last term? Jeffrey?
12.
A sub 12. Yeah. So we're going to have 3 times 12 plus 4, which is going to equal 40. The last thing I have to know is the number of terms. Now, the other class pointed out that sometimes our n's don't quite match up, right? Because this n is usually my number of terms, and that is. So sometimes our n's don't match up, depending on if our terms aren't right. So the way I think of it is first term, last term, and then come up with your number of terms. So I'll say number of terms. And how many terms do we have on this one? Careful. Jack. We have 14 terms. Yeah. We have 14 terms because if it was 1 to 12, I'd have 12. If it was 0 to 12, I would have 13. It's negative 1 to 12, which is 14. All right, that's all the information I need. So we're going to find our sum of our 14 terms. That's going to equal my number, 14, divided by 2, plus my first term, which is 1, plus my last term, which is 40. And our total sum is going to be 287. All right, so anytime it says find the sum, the first thing you're going to do is you're going to recognize whether it's arithmetic or it's geometric, and then you go from there. Okay, the first thing I want to go over is the homework really quick. And more particularly, I posted on Edmodo, don't worry about number 9 if you saw it or anything. I don't like what happened on number 9. I want to see which one we're on. Let's see if we're just on the untitled one. So if you looked at number 9, so number 9 said a poker hand. A poker hand consists of 5 cards drawn from a deck of 52 cards. How many different poker hands are there consisting of ace, king, queen, jack, and 10? If you looked at the solution manual, and correct me if I'm wrong for people that saw it, they basically said do 4 times 4 times 4 times 4 times 4, which is 4 to the 5th. I believe they had that as the answer, right? So a lot of things wrong in here, the way I'm reading the question and how I read their answer. So they're saying there's 4 different suits. So you can have the ace of hearts, ace of diamonds, ace of clubs, ace of spades. So you have 4 suits to choose from those. And so that's why they had the 4 times 4 times 4 times 4 times 4. Here's where this breaks apart. Can you ever have 5 aces in a hand? No, you can't have 5 aces in a hand. Plus, they're not accounting for a whole bunch of other factors. So all in all, this is just not the correct way to think about this. And so I'm going to go ahead and I'm going to scratch that off because there's a much better way to do this problem and a much easier way to think about it. And it is this. If I have a poker hand of 5 cards, does it matter the order? Does it matter if I got a king first or a king second or a king third? As long as I have a king. In fact, when you get your cards, you usually reorganize them, right? Doesn't matter what order they were dealt in. So order does not matter in this. So this shouldn't even be in the permutation section. They were trying to make you think about it in a very complex, what I think is kind of a dumb way. All right, so we're going to scratch this one out. We're going to forget about it for a second. We're going to realize that the order doesn't matter, and that's going to lead us into today's lesson, where we're going to learn about combinations where order doesn't matter. But before we get into that, do we have any questions on any other problems on here? Because I would, yeah. Number 11. Oh, it's the same problem.
Oh, it is. Makes sense.
It's a good thing you had a question on it then. No, it was the exact same question as number 9. Nice. Your question was, why is there 2 of the same on? That was your question, I bet, right? Why are there 2 of the same problems on there? Yeah. 51. Before I get to 51, I just want to make sure we recognize that 0 factorial equals 1, so this is really 5 factorial over 1. All right, so don't just see zeros with factorials and go, it's undefined. I just want to say that. All right, 51. 51, we're taking a test. How many ways are there to choose the answer to a test that consists of 5 true or false questions followed up by 6 multiple choice questions? Were you confused at all by the answer key? Or are you just not sure how to start it?
Oh, well,
Both? Okay. So we have 5 true or false questions, right? So we're going to do our true and false first. So I have 5 true and false questions. 1, 2, 3, 4, 5. How many ways can I pick the first one? 2 different ways. Yep. How many ways to pick the second one? And then. And so the multiple choice section is 2 times 2 times 2 times 2, which the book converted to 2 to the 1, 2, 3, 4, 5th power. All right, that's my true and false section. Does that make sense?
Yeah.
Okay. And then when you get to multiple choice, how many are there for each of them? There's 4 choices for each of them. And how many questions are there?
6.
There's 6. So that's where they got 4 to the 6. You know, we have 1, 2, 3, 4, 5, 6 possible 4s. And then you should just do 2 to the 5th times that 4 to the 6th. Yep. Because it's all strung out, right? Because I could have all true, and then we got to worry about every one of these. I could have all these true except for 1 false, and I have to worry about all of these again. So you have to multiply them together. Jeffrey. 45. 45 says, the computer password, how many different 3-letter combination passwords are available if any letter can be used, but repetition of letters is not allowed? So I just have to pick 3 letters. We don't repeat any letters. So how many choices do I have for my very first letter? Jack?
26.
And then for my next one? 5. And then for my last one is 24. And that's going to be your answer. Then I got this question wrong on a test, and I still remember it. So I thought there was 28 letters in the alphabet for some reason. Like, I just swore up and down it was 28. Like, it wasn't just I accidentally wrote 28 down. Like, I was positive we had 28 letters. So if you did that on a test, I wouldn't take any points off, just because I felt that pain of, well, I don't feel like counting the letters on a test. All right. All right. Other questions? Rosie, since you came in late, I'm just going to rehash. We're not worried about 9 or 11. All right? The book, I don't like it. I don't like it one bit. It hurt my soul a little bit. how they did it, and it doesn't make sense to me. And basically, the way they did it is wrong, first of all, and it's wrong a second way because you can't have 5 aces. They're assuming you can have 5 aces in your hand. All right, so don't worry about that. We'll find a much easier way to solve this problem. The key is that order doesn't matter in that one. All right, other questions, though? Okay, then let's get to today's lesson. So permutation was order mattered. So today we're going to talk about combinations. What do you think the difference between combinations and permutations is? If permutation order matters, what is combination? It doesn't matter. So I just want to came up with 2 examples of where order matters and where order might not matter. So the first one is, if you have a fruit salad and you have apples, grapes, and bananas, does it matter what order the apples, grapes, or bananas are in your salad? Except for Mike, no, they don't. They don't matter. They're just in there. They're in there. There's no specific order for them. I just have those 3 items in my salad. On the other hand, if you have a combination to a safe, you have to put every digit in order. So order definitely matters. So this second example right here is called a permutation, because order matters. And the one above is a combination. Well, that leads us to a very bad problem that we do every single day. We have combination locks, right? Doesn't order matter on our locks? So that's why I came up with the point that we should really call these permutation locks. They're not combinations, they are permutations. So from now on, you have to call your locks permutation locks. From now on, all right? I guess it's kind of hard to, because we already have it ingrained in our mind that we have combination locks and order matters. We have to flip that assumption, right? Combination is where order doesn't matter. Permutation is where order matters. All right, if you could take one thing away from today's homework when you're working on it, is can you tell the difference between when order matters and order doesn't matter? Everything else we can fix, but if you can't get those 2 things straight, this becomes really tough chapter for you. All right, so we're going to fill out this little chart so we can quickly look at it anytime we need to. So permutation, order matters. So it matters here. For combination, it does not matter. And our notation for permutation is going to be permutation of how many things we can choose from and how many of those we're picking. The other way you may see it put is N, P, R, where our pool's first and how many we pick is after. And in fact, this is a button on your calculator. This is a button on your calculator. If you press your math button and you go to your probability section, you can actually calculate permutations with your calculator. And in order to do that, notice it's NPR. You have to put a number in first, then do your permutation button, and then do how many you're choosing. So if I did 5, choose 3, I'd plug a 5 in. Then I'd hit my math button, the probability button, go to this button, and then I'd put the 3 in after. And it will pop out 5, pick 3 with permutations. The reason why I show you that is because on the test I will make sure I write down there, make sure you show what equation, show the whole equation or something. All right, for combination, kind of the same, except we're going to use a C, and we use our N and an R. Or we can have N, C, R. And the final way we might see it is you might just see it with parentheses, where your N is on top and your R is on bottom. So if you ever see just this, it won't say combination, but if you just see that, it's an implied combination. All right, that's another way to write combination. Someone's excited about that. All right, the formula for permutation. That is just my n factorial over my n minus r factorial. So that's my total factorial over my total minus how many I'm picking factorial. Now on the board, it's still up there. We should have less combinations than we do permutation, because in permutation, order matters. So what I said is, maybe I'm picking 3 letters. Maybe I'm picking 3 letters and I'm picking, I'll write it up here too. So I'm saying I need a 3-letter password. All right, I need a 3-letter password. And here's my 3-letter password. And let's say one of my passwords is KAS. And the other password I'm choosing from is SAK. Now if I'm doing passwords, each of these are 2 different items, right? If I'm doing a password on my computer, I have to plug this in order, KAS, or I have to plug in SAK. So that's 2. If this is a permutation and order matters, so for a permutation, these are 2 different options. However, with combination, order does not matter. So in a combination, this would actually only be one choice. This would be one choice. All right, that's why with combination your number is going to be a lot smaller, because it gets rid of repeat stuff. Since order doesn't matter, it gets rid of a whole bunch of repeat things that are just a changed up order of things. So that means our combination is going to look very similar to our permutation, because we are finding those exact same numbers. So we do have n factorial over n minus r factorial. But I'm going to get rid of all those ones that are just repeat ones. And we're going to do that by multiplying by r factorial on bottom. So the only difference between our combination and our permutation formula is our combination has less items in it, so we're going to divide by r factorial to get rid of the ones that are just changed up order. All right, let's go do some examples. All right, so our first one says a 3-person committee is needed to study ways of improving public transportation. So I'm going to stop there. 3-person committee. Does it say we have a committee member, supervisor, whatever? Does it matter which order I pick my? So if I say you 3 are my committee, or I say Jack, Ethan, Mike are, does it matter? Does order matter? No, it does not. So order doesn't matter in this one. So it's going to be a combination. Order doesn't matter in combination. Yeah. All right, so we're going to use a combination, and it says how many committees could be formed from the 8 people on the board. So that our combination is our total number of people we can pick from, comma, how many I'm picking. So I'm picking 3 people from those 8. And our combination formula is 8 factorial over 8 minus 3 factorial times 3 factorial, which equals 8 factorial over 5 factorial times 3 factorial. Now I know your calculator can do this. We can do 8, and remember you have the factorial button in that probability section as well. So you can just type in 8 factorial over 3 factorial times 3 factorial. Make sure you put these in parentheses. Or let's pretend for a second I don't have my calculator. And I want to see if I can do this by my hand. So a way we could break this down is I say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Whew. Exhausting. Or everything's being multiplied. So the first thing I'm going to notice is I have 5, 4, 3, 2, 1 here. and I have 5, 4, 3, 2, 1 here. So those will both turn to 1 when I divide them because they're going to be the exact same number. Another thing I'm going to notice is this 3 times 2. Let me change my color. Let's use green. I have this 3 times 2 in the bottom, which is equal to 6. So those will cancel out. So in fact, I can actually do this whole thing in my head, and it's just 8 times 7, which is going to be 56. If ordered matter, it would be a much bigger number. If I was saying we're choosing a president, a vice president, and a secretary, that number would be a lot bigger. But combinations are generally going to be smaller numbers than permutations. Make sure you kind of have an idea of how you could do it by hand, just in case I make a non-calculator section and I put a problem like this on there. Alright, so make sure you know how to do this. It's all well and good if you use your calculator because that's going to be the majority of the test, but I can always throw one on here and say you can't use your calculator. Okay? Alright, our next one. This one's a little trickier. We have 12 students that are on this project. The director needs 3 phone solicitors, 4 door-to-door solicitors, and 5 magicians. And how many ways can each of these jobs be assigned? Now here's what I'm going to tell you. It can't be both combination and permutation. So what I'm going to do is I'm going to stop reading after the director needs 3 telephone solicitors. I'm going to stop right there. Does that sound like combination or permutation if I'm just picking 3 people to work the telephones? Does order matter? What was that? It is combination. It's combination because you're a telephone operator. Whether you're telephone operator number 1, 2, or 3 doesn't matter. You're just a telephone operator. So this right here, 3 telephone solicitors, that's a combination. And as soon as we have one combination, it's all going to be combinations. So order does not matter. So we're going to use combination. But we're picking things over and over and over. Kind of like if I put my hands and I pick up 3 people to be my telephone solicitors and I throw them as telephone. Now I'm going to go back in that bag and I'm going to pick 4 more to be my door solicitors, throw them as door solicitors, and finally I pick them up, my magicians, and throw them out. So I'm picking 3 different times. So in fact, this is 3 different combination problems put together. So we have 3 telephone solicitors. My other set is going to be 4 door-to-door solicitors. And my last one is going to be 5 magicians. So how we're going to write that is, I'm going to write my telephone one first. My telephone people. My telephone peeps. That says I'm going to choose 3 out of 12 students. So it's a combination problem. I should probably use green again so you can see, match it up. But my telephone is going to be, I have 12 people to start off with, and I'm choosing 3 of them to work the telephones. My next one is door to door. Here's where it changes a little bit. I went in there and I picked out 3 people and I threw them to the phones. Do I still have 12 people to choose from?
Nope.
No, I have how many people to choose from? I have 9 people to choose from. So that's going to change our number. We are now going to have 9 people to choose from because I lost those 3 people to the phones. Oh, I'm actually choosing 4 people to go door to door. I'm choosing 4 people to go door to door. How many people do I have left now that I threw 4 aside to do the door to door? I have 5 people left, and I have magicians to fill. That's a weird thing just to pick. You're a magician today. I feel like you'd have to know how to be a magician. All right, so we only have 5 people left, and we are choosing 5 people. And we're going to multiply all those together. Let's think about that 5 choose 5 really quick. If I have 5 people, and I have to choose 5 magicians, how many ways can I do that? Yeah.
Just one.
Just one way. Would that be different if it was permutation and order matter?
Yeah.
Yep. But in combination, we're all magicians, so I just grab you 5 and you're magicians. Doesn't matter which order I grabbed you in. So, in fact, I already know this is going to be 1. So if you wanted to, you could just put 1 down for that. I'm not going to. I'm actually going to write all these out. So I'm going to write out this multiplication. Well, our first one is going to be 12 factorial over 12 minus 3, which is 9 factorial, times the 3 factorial. And then we're going to multiply the next one, which is 9 factorial, over 9 minus 4, which is 5 factorial. If you need to, I don't know how far we are or what we did last year, you could just rewrite this as 9 minus 4 in case you're ever forgetting how you did it. And then it's going to be times 4 factorial. And then it'll be 5 factorial over 5 minus 5, which is 0 factorial, times 5 factorial. Well, 5 factorial over 5 factorial, that's just going to cancel out and turn to 1. Now, I had a great question. In my other class, so I'm going to ask it to you. Do you think I could do 9 times 3? Maybe easier one. 3 times 5, and it'd be 15 factorial. Do you think that would work? It does not. It does not. Do not just multiply these numbers and put a factorial after. So do not do that. But we could do, to make our life a little easier, is we could look at that and just say, hey, I have a 9 here. I have a 9 right here. I have a 9 here. So I could cancel those guys out as well. And then I would just have 12 factorial over 3 factorial times 5 factorial times 4 factorial, which we could do in our calculator. Just be very, very careful that everything in the denominator you put around a parenthesis. So if I did 12 factorial divided by open parenthesis, 3 factorial, 5 factorial, 4 factorial, close parenthesis, if you're plugging that in your calculator. And this is going to actually come out to 27,720. 27,720. This is about as hard as our combination problems are going to get in this section, okay? Because we have 3 different things happening, and we have to account for all of them. All right, our very last one is 50 people purchase raffle tickets. 3 winning tickets are selected at random. If the first prize is $500, second prize is $100, and third prize is $50, how many different ways can the prizes be awarded? Do you think order matters? Do you care which one you get?
Yes.
Would this be the exact same? 100, 50, 10, or 150, 10? Would you care which one you got? So does order matter? Yeah, order definitely matters in this one because there is a distinct advantage to being 1, 2, or 3. So order definitely matters. Yes. So that must mean we're using permutation. And our permutation is going to be, I have 50 total people. I am choosing 3 winners. So my formula is going to be 50 factorial over 50 minus 3, which is 47 factorial. Once again, if you need the extra notes, just write that is 50 minus 3. Well, we could take out our calculators and figure that out, or we can be a little smarter about it and notice that we have 50 times 49 times 48 times 47 times ... Well, our bottom is 47 times 46 ... So these would cancel out, and we'd just be left with 50 times 49 times 48, which is going to come out to 117,600 possibilities. Questions, comments, concerns? So the hardest thing we should be working on right now is deciding whether order matters or doesn't matter. Okay? The last one we're going to talk about, well, we have one problem and then we have just an additional problem. Just another practice problem like the other one. What if we have identical objects? Things that just would be the exact same whether the formula would know it or not. Well, my question to you is how many different ways can we arrange the letters in the word Mississippi? Here's the problem with this one. This sounds like a permutation problem, right? Because doesn't order matter? Does order matter in spelling? Yeah, I bet your English teacher would agree that order, I can't spell the, H-E-T, that's a completely different word. So order definitely matters. So this is a permutation problem. Here is where the trouble lies. Notice if I spell Mississippi, notice my two S's. I'm going to say the one on an underline is a different S than this one. In permutation, it would count Mississippi as one, and it would count Mississippi with the S's flipped as another possible spelling. Is this a different spelling? No. So we have to account for the fact that some of these, even though permutation is going to say, hey, that's two separate things, we have to tell it, nope, it's one thing. Mississippi, no matter what order you put your I's and your P's and your S's, will still be Mississippi. I want completely distinct new things. When that happens, we have something called a combination with sets of identical objects. And rather than going through this whole thing, we're just going to run through an example. All right, and then you can look up here to see if it matches. And my hint to you on these is most of these are spelling ones. So if I'm asking you how many ways to spell something, it's probably this type of problem. Okay? All right, how many different ways are there to spell Mississippi? Well, the first thing I'm going to notice is how many letters I have. So my number of letters. I have 11 separate letters. Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 letters. We have repeat letters, so we're going to count how many times each letter is repeated. Well, M, I only have one of those. For I's, I have 1, 2, 3 of those. I have 4 of those. I have 4 I's, not 3. I have, how many S's do I have? I have 1, 2, 3, 4. I got 4 of those. And finally, for my P's, I got 2 of those. All right, with spelling, with repeat, all we need to do is count all of our letters, how many things are repeated, and all we're going to do is we're going to take our total number of letters, 11 factorial, and we're going to divide by each of those as a factorial. So 1 factorial times 4 factorial times 4 factorial times 2 factorial. And if you plug that in your calculator correctly, you're going to come up with 34,650. Now your calculator does not have a repeat button, so you just have to know this. This is something you have to know. There's no calculator workaround. All right, so you have to know how to plug this in your calculator as well. And once again, you'd write 11 factorial, division sign, open parenthesis, all this, close parenthesis to get your total. All right, last example. It's kind of like that group one, because I think those are the hardest ones for combination. So it says a company employs 9 male welders and 7 female welders. How many different committees if can be formed, it should be can be formed, if a committee of 3 male welders and 2 female welders could be chosen? So how many different committees can you form if 3 male welders and 2 female welders could be chosen? So if I choose 3 male welders, is there a hierarchy? Or does order matter? Does order matter if I just say I'm picking 3 welders? No. There's no welder 1, welder 2, welder 3. Order doesn't matter. I just pick 3. Doesn't matter who's first. So right there, if I'm just choosing random 3 male welders, and I'm going to choose 2 female welders, this must be a combination problem because order does not matter. So it's a combination problem. We have 2 combinations. We have pulling 3 male welders and 2 female welders. So for the males, for my males, we are going to have a combination of, well, we have 9 male welders, and we're choosing 3. And for the females, we have 7 females, and we're choosing 2. We just have to multiply that sum together, or multiply those 2 things together, and we will have our total number that can be chosen. So that is going to be 9 factorial over 9 minus 3, which is 6 factorial, times 3 factorial. And then we're going to multiply that by 7 factorial over 7 minus 2, which is 5 factorial, times 2 factorial. And you may want to break this apart in your calculator, or you might not. However you plug it in, you should come up with 1,764. Total choices. Alright, so for your homework, it's going to start out mostly just combination and factorial problems. But then the back side is you actually have to decide whether it's permutation or combination to decide what you're going to use. So make sure you focus on, can you decide whether it's combination or permutation? The formulas can come later. Alright? So your big thing is just being able to decide whether it's combination or permutation. Alright, you have a couple minutes to kind of look over the problem, see if you have any questions.